All right, let's do a little more with measures of central tendency. I thought it might be fun to take a look at how to calculate a GPA. All right, this is really getting at the idea of a weighted average. Like the fact that some, like the grade for my course, for instance, you can't just add up all of your grades, like your homework, your quizzes, your tests, and divide by a number and get your average, because tests are weighted more than homework, right? So homework's only 50% of your grade, where tests are 50% of your grade. So you have to be careful about weighted averages and trying to understand that. So here, we're going to be under the assumption that an A is worth 4 points, a B is worth 3 points, C is going to be worth 2, D is going to be worth 1 point, and an F is worth no points. Okay? And so to calculate your GPA, you have to consider the fact that this class counted for 4 credit hours and you earned a B. So you get 3 points for each of those 4 credit hours, giving you 12 quality points. You multiply. It's kind of like the example we did with the salaries at the company, right? So the A that you made in English 101 is worth 4 points, but the class was only 3 credit hours. So it still was worth 12, even though you made a higher grade, because the class was only 3 credit hours. History, you made a B, which is also 3 points, and it's worth 3 credit hours, so that gave you 9. A C is worth 2 points, but it's worth 4 credit hours, so you got 8 total for that. And you made an A in this class, which is worth 4 points, but the class is only worth 2 credit hours, so that gives you 8. So if you add up those, you're going to wind up with 49 quality points, and we're going to divide that by the total here. So that's 7, 10, 16 credit hours. So when we do that, we wind up with that turning out to be about 3.06 for a GPA. So you don't divide by 5 classes, you divide by 16. Okay, so 49 divided by 16. So see how that was very similar to what we did earlier with the one dealing with the salaries? When we did the mean of that, it was also like a weighted average. Do you see how we took the total of all of the salaries? We didn't divide by the 6 different salaries, we divided by the 20 different salaries. So it's just like that. GPA is just a weighted average, okay? All right, so that's one thing I wanted you to know. Then I want to do this problem. Here we have a student that took 6 tests, and we want to calculate, like we did before, the mean, median, mode, all that. So let's go in and get the mean. Let's get the median. Let's get the mode and get the mid-range. Okay. So there's only 6 of them, so it only takes a second to get them in order. So we have a 44, 279s, okay, 44, 279s, an 81, an 89, and a 90. Okay, so there they are. All right, so for the mean, I would add the 44, the 79. They didn't really have to be in order, right? But I would add up all of those values. And I would divide it by 1, 2, 3, 4, 5, 6, how many I had. And that 462 divided by 6 gives me 77 for the mean. Okay? Right, for the median, now that they're in order, and there's 6 of them, there's 3 low ones and 3 high ones. So the middle of those 2 is what I need. So I'm going to add up the 79 and the 81 and divide by 2. And that would be 160 divided by 2, or 80. And you can kind of tell 80 would have been the middle number. So it'd be okay just to say 80 there. And for the mode, that would be 79, since there are 2 79s, right, here and here. And then for the mid-range, you would take the lowest one and the highest one and add those, hit enter before you divide by 2, If you did that, you'd wind up with 134 over 2, which turns out to be 67. Okay? So in this case, which of these do you think might best be the best measure of central tendency? What I'm really asking is which do you think is representative of Theo's ability? So I think you might argue the mean, that he did make a 44 on the test and that should be included. But I think you could have argued maybe the median would have been better because he just did pretty good on all the tests except for that one. Okay. So I would probably have said, as an indicator of his ability, probably the median, since all scores were A or B virtually. I mean, you did have a couple 79s, but that's almost a B. So I'll say we're virtually A or B except the 44. And that would have really, the 44 really brought down the mean. I'll just say the 44 brings down the mean. I don't think the mid-range would have been a good idea on that one because of that really low score. And the mode, you're sometimes just lucky when the mode seems to be representative of the data set. Like, there could have been two 44s, and then, you know, that you wouldn't have wanted to use the mode. Okay. Now, this question is another thing you're sometimes asked. And in fact, students often ask me this, you know, what would I need to make on the next test in order to get a such and such average? All right, so that's what we're being asked here. Okay, what means he's going to be allowed to replace that lowest score. So, you know, he had a 44, a 79, another 79, an 81, an 89, and a 90. And then he's going to be able to replace that one with something else, and we want the new overall average to turn out to be 85. Okay, so you could do this using a trial and error type approach. You could take whatever you want to put there. Like you're trying to get an 85, so you might think, well, let me try 85. So I could try 85 and then see what the average would equal. And then if it's too low, try something bigger. If it's too high, try something lower. You know, so then try something else, right? And keep adjusting until you hit the right spot. Okay, so that's a very valid approach. It would work well. All right. Oh, the other thing you could do is you could think about how all of these right here then would need to add up to be, if I multiplied by 6 to get rid of that 6, then all of these scores, oops, not that one, whatever that one is, plus all the ones other than that 44 would have to add up to be what an 85 times 6 is, which is 510. And then you know those add up to be 418. And so you can kind of use your algebra skills to think, so let me take, now I'm to here, let me take and subtract 418 from both sides. And if I did that, I could see that a 92 would do it. But again, don't, trial and error would be okay. Or you could use your algebra skills on that. All right, and then just a little bit more. I included a chart here from the text that allows you to kind of compare, like see what the advantages and disadvantages of these. So you see the strengths and weaknesses. So the mean does factor in all the values in the data set. Okay, but it can be adversely affected by one or two really high or really low values. That's the problem with it. The median is not affected by one or two, which is why we sometimes use it, or they use it to report things like salaries, the median salary, or the median housing price. But maybe it's important to consider the really low or the really high values. and it ignores those, okay? And then with mode and mid-range, you can see there what it has to say about that, okay? Just one more thing I want to comment on. We're not going to do too much with this, but just knowing what the mean is, or a measure of central tendency is for a data set, really doesn't give you a good sense of what the data set is like, okay? So you a lot of times want to report maybe what the mean of a data set is together with some measure that gives you a sense of how spread out, how far apart the data would be. And the only one of these are called measures of variation or measures of dispersion. Some books call it measures of dispersion or spread, are things like range, variance, and standard deviation, but we're only going to do the real simple one, the range. You'll do the others if you take Math 110 or statistics. And all you do for the range is take the highest and subtract the lowest. Okay? So here we have a list with the weights of 4 large dogs, and then we have a second one with the weights of small, medium, and large dogs. It wants us to find the mean, median, and range for each. So let's look at the mean for each, and then do the median for each, and then consider the range. All right, so we really need them in order. So let me do that real quick. $75, $85, and then there's one that's $125. And then list 1 just had 4 values, so it's a little easier to see without even doing that. You could probably have done it. Okay, so the mean on the first list, if you added those up, would be 261 divided by 4 would turn out to be 65.25. On the second one, when you add all those up, you get 512, and there's 8 of them. And that turns out to be, gosh, kind of close, like 64. Okay. All right, for the median, the first one had 4, so that's an even number. So we have to get halfway between the 60 and the 70. Okay, we could do that by adding them and dividing by 2, or we can just see it would be 65 if we were halfway between those two. The median for the second set, there's 1, 2, 3, 4, 5, 6, 7, 8. So we still have an even number. So we need to be halfway between 55 and 60. So we could add them and divide by 2. Okay, so you would get 115 divided by 2. And if you did that, you'd have 57.5. Let me try to write that better. For your median. Okay, your middle number, okay? And then the range would have been highest minus the lowest, period. And so 73 minus 58 would be 15, where over on the second set, 125 minus 30 is 95. Okay, so we have a similar mean, and even the medians aren't that different, but much more what you might call variability in list 2. The list 2 data is more spread out. Just looking at the mean, you wouldn't have a sense of that. You would almost have to have seen the raw data or known what the range would be to tell how spread out those data values were. All right, a similar thing happens if you go back to the Vandelay Industries. Remember how the one person, probably the CEO, made $974,000, but then the person getting paid the least just made $38,000. So the range would have been just that difference. That would have been the $936,000. That's all there is to calculating the range. So both the range and the mid-range use the high and the low. But remember, mid-range, this is range. Don't get it confused with a mid-range, which is a measure of central tendency. For that, you add the high and the low and divide by 2. Okay, so we did that earlier. And the mid-range for that turned out to be 506,000. Okay, so we're not talking about mid-range here. We're talking about range. So you will need to know that difference between a range and a mid-range. All right, so that's the most important stuff. You'll need to be sure you know the measures of central tendency, mean, median, and mode, mid-range, and then also understand how to find the range in a data set. Okay, so range only uses the high and the low value. So if there's an extremely high or an extremely low value, the range might make it look like there's a lot more variability in the data than there really is. So there's some other measures like variance and standard deviation that are used to describe the variability in a data set. We don't cover those in this class though.